why very few people have joined?
I don't know. Today morning DBMS also there was nobody.
Okay, okay.
Looks like maybe normally what happens is that in the middle course people will be slightly lethargic actually towards.
Yeah, yeah. So we'll wait for how many people are joined in the DBMS session morning?
Yeah, DBMS, there were, I joined at 9:20. By the time they had already closed the session because there was no participation that was.
Right. Okay, and how did you come to know that they closed because there's no participation?
I had put a message into Discourse why there is no session. Then someone replied that they had waited for 15 minutes or something.
Okay, okay. But anyway, we'll wait for a few more minutes and after that we'll start the session.
Yeah, by 2:10, I think we can start. That will be better. People will be just.
Yeah, yeah. So others, please wait. Please wait for a few more minutes. Okay. Let us wait for the count to go to 20, 20 or 15 at least. So after that, we'll start the session. Okay. Yes, thanks. Yeah. So in this session, we'll discuss week 8 problems. Okay. We'll still wait for others, but meanwhile, I'll just share my screen so that others will know that session will happen. Okay. So give me a second. Are you able to see my screen?
Yeah.
Yeah. Okay. So we have exactly like 16 people who are removing the host and me. So we'll wait for 3 more minutes and then we'll start. Okay. Sorry for the delay. Did any of you guys give the programming exam today, like DBMS exam? Have you guys given no, not DBMS, sorry. That Java exam, I guess, is happening today, right?
Yeah, that could be the
System
reason
commands and Java exams are
for
today.
the low
Yeah.
participation also. People could be either preparing or attending, and tomorrow also there is a session, not 20.
Sir, tomorrow there is exam for system command.
Today also it is there, no? 25 and 26th it is.
Yeah, 25 and 26. Yeah.
Right.
Yes, sir. Today also we are having our exam.
Yeah, that could be the reason for low participation.
Yes. So, and tomorrow you will not be having this MLP and MLT, right? Because for taking
Tomorrow
MLP,
system commands are there, sir.
okay. For you to take MLP and MLT, you should be completing MLF, right? Am I correct?
Yeah. Yes, sir.
Some commands, and I think Python also is tomorrow.
Yes. Python is also tomorrow. Okay. Anyway, let's begin the session. I think we have enough number of people. Yeah. So in this session, we'll be solving the problems of week 8. Okay. So this is the first problem. Like if f of, shall we begin?
Yes, we can.
Yeah. Okay. So if f of 6 equals to 3 and f dash of 6 is half and f double dash of 6 equals to 2, right? What is the value of what could be the value of f of 7? You could use use Taylor series to solve for this. Taylor series expansion, right? You could use that. Okay. Use the Taylor series expansion to solve for this problem. I hope all of you guys know the Taylor series expansion. Okay. I'll give you guys, since this is easy problem, I'll give you like 4 minutes to solve, and after that we'll look at the solution. Okay. After 4 minutes, we'll look at solution. This is the problem. If you have completed the problem, right, please do not mention the answer in chat box. Yes, I was able to say that. Please do not mention. Please do not mention whatever value you got in the chat box. Please do not mention. Let others be given time to solve.
Excuse me, sir.
Yes.
So where can we enter our answer?
What? No. You will not be able to enter the answer. We'll just be discussing after this. Okay.
Okay, sir.
Okay, so shall we discuss the solution? Okay,
Yeah.
yeah. So now the details that was given was that we were given f of 6, right? F of 6 value is known to us. What is the value of f of 6? Can anyone tell me? Hello, am I audible?
Yeah. F of 6 is 3.
Yeah, f of 6 is 3, f double dash of 6, f dash of 6 is half, and then f double dash of 6 is 2, right? 3. Are you able to see my screen? The notebook, you are able to see my screen, right?
Yeah.
Okay, okay. So, what is the Taylor series expansion of f of x plus nd? It is f of x plus nd dash of x. Okay, plus d double dash of x plus and so on, right? So, nothing but 2 or 2 factorial, both the same. Here we need to find f of 7. F of 7 can be written as 6 plus 1, right? So basically x is equal to 6 and nd is equals to 1, okay? So this is basically f of 7. F of 7 will be equals to now f of 6 plus 1 into f dash of x is 0.5. So plus nd the whole square by 2, which is nothing but nd is 1. So nothing, which will be 1 by 2 into f double dash of x is 2, right? It's nothing but 3 plus 0.5 plus 1, which will give you 3 plus 0.5 plus 1, which will be equals to 4.5, right? So basically, f of 7 using Taylor series expansion is equals to 4.5. All right. Uh, did any one of you get a different answer, or this is clear, right? Is this clear?
Right.
Yeah. Okay. We'll move on now. Okay. So this is the next problem. F of x comma y equals to xy square. Taking eta equals to 1. Okay. Taking eta equals to 1. And then x naught y naught equals to this is the initial arbitrary value we start from. X naught y naught equals to 2 comma 2. What will be the value of function after 2 iterations as per gradient descent? This is clear. This is our objective function. This is the objective function. Basically we need to be minimizing this, taking eta equals to 1, then and then x naught y naught, which is the initial value, okay, as 2 comma 2. What is the value of this function f of x comma y after 2 iterations as per gradient descent? Okay, this is clear. First you need to be finding x1 y1, that will be a first iteration, and after that in second iteration you need to be finding x2 y2. Using x2 y2 by substituting here you'll be getting the value of function, that is you need to find f of x2 comma y2. Okay, is this clear? Hello?
Yes, sir. It's clear.
Yeah, okay. So try to solve this and then please do not mention your answer in the chat box. Okay, this is not a single variable function, this is multi-variable function, so you need to be using the gradient. Okay, for this I'll give you like 5 to 7 minutes to solve, and after that we'll look at solution.
Sir, I just have to clarify. We have to find x2, right?
You need to find x2 and y2, right? The ultimate answer, the ultimate value which you need to find is you need to find f of x2 comma y2.
Okay, sir.
Okay, yeah. For those of you who have joined now, please look at this problem. Okay. Using gradient descent, you'll be finding the value of this function after 2 iterations. Okay. This function has 2 variables x comma y, so you need to be using gradient. If you have completed, please raise your hand so that I will know that you guys have completed. Please raise your hand once you're done. Okay, so shall we look at solution? None of you have completed this problem. No, do you need more time or shall we look at solution? Hello. Can you hear me?
Yeah, we can hear. You can move on to the solutions. That could be.
Yeah. So others, do you agree? Shall we move on to solution?
Yes.
Okay. Okay. So let us look at the solution. We have this step of x comma equals to xy square, and then initial assumption is x naught y naught is 2 comma 2. Okay. So what do we have here? We have that we have f of x comma y equals to xy square, and then x naught comma y naught equals to 2 comma 2, right? So according to the gradient descent, what is the formula for xn plus 1 comma, sorry, what is the formula for this xn? X you could say, right? Where x is a vector. Can anyone tell me the formula? Xt plus 1 formula according to gradient descent. No one?
Yes, sir, I can tell.
Hello.
Yeah. Please tell.
So xt plus 1 equals to xt plus nx, eta x minus f dash xt.
Eta what?
Eta x minus f dash xt.
Eta x minus dash of x is this?
So, no, sir, in multiplication, minus eta into.
So minus eta into f dash of x. That's what you're saying. We won't have x here, right?
This.
Do we have x here? We do not have x here, right? This
Have
is
two coordinates.
Del.
Yeah.
Is it
So del-
gradient?
del.
Del
It
f
should be
of
right.
del
right,
f of.
right. It should be if it has been a single variable, then the f dash of x will be correct. Since it is this multivariable one, it should be del f of x. Okay. So what we have here, we have this xt as 2 comma 2, right? 2 minus eta they have mentioned as 1. So what will be this del f of x? It should be dou f by dou x and dou f by dou y, right? Right. So this will be since this is x naught y naught, so this will be x1. Okay. So what we have here is dou f by dou x. Right, and write down dou f by dou x here. Dou f by dou x is just partial derivative with respect to x, so this will become y square. Yeah. What is the value of dou f by dou y?
2xy.
Yeah. 2xy, yes, correct. Okay. So now what we have is, by substituting this, we could get that x1 equals to minus dou by dou x at 2 comma 2. What is the value of this y square? It is equals to 4, right?
4. Yes.
And similarly, this 2xy, it's going to be equal to 8, right?
Yeah.
So this is going to be equals to 2 minus 4 minus 2, 2 minus 8,
Minus 6.
right? This is x1. But we need after first iteration. But we need to find after 2 iterations, right? So we need to go for second iteration. Then x2 is going to be equals to now minus 2 minus 6 minus of this y square, where now y is equals to minus 6, right? So y square will be 36, correct? And this 2xy, it's going to be 2 into minus 2 minus 6. It's going to be 2 to 4, 6 4s are 28, right? Am I correct?
So how this came
24, yes,
36 and 20?
Yeah, 6 4 24. Sorry. Yeah. Huh? How did we?
How we came here, like 36 and 24, how we get this value?
How we got this 36? Is it?
Yeah.
So this should be now for x2. It should be x1 y1 minus of dou by dou x dou by dou y at x1 y1. Correct?
Yes.
What is dou by dou x? Dou by dou x value is y square.
Y square. Yeah.
And what is the y value here? Y value is minus 6, right?
Oh, okay.
So we got 6 square 36, and then later we need to compute this 2xy, which is going to be 2 into minus 2 into minus 6, right? 6 4s are 24.
Yes, and now I got the answer.
Okay. Now what we have is we have this value as minus 2, minus 36, minus 38, and then minus 6.
Minus 2.
Yeah, minus 6, minus 24, it's going to be minus 30, right? Okay. Now the value of f of x comma y after two iterations, right? Which is nothing but f of x2 comma y2, it's going to be equals to xy square, which is nothing but minus 38 into 30 square. Okay, this is the value. All right, is clear? Hello, is this clear?
Yes, sir.
Yes, sir.
Yeah. Okay, I'm not going to compute the value because that value will be like very big. Okay. Okay. So now in this problem, it's exactly similar to this. Okay. But then this is even better. I mean, here we are not even like we are not even trying to find this f of x comma y. We just need to find this. They're given x naught, y naught, and then they just ask for what is the value of x2. Okay.
Yes, sir.
All right. Yeah. Please solve for this. You just use the formula as exactly as before, and then try to solve for this. If you're completed, please raise your hand. After that, we'll look at solution. We'll wait for 2 more minutes and then we'll look at solution. Okay. Okay, so we look at the solution now. Okay. We have f of x comma y equals to xy plus 2x minus x square minus x square minus 2x. Okay. F of x comma y equals to can someone tell me what is that value? 2xy plus 2x 2xy plus 2x minus
Minus x square minus 2y square.
minus x square minus 2y
y square
2y square or 2y.
2y square
Okay, yeah, 2y square. And then what is the value of x naught, y naught they have given?
Minus 1, minus 1.
Okay, it is minus 1 comma minus 1, right?
Yeah.
They asked to find x2, all right?
Yeah.
When they said x2, it is just this one, okay? Not the overall vector, they just asked to find this x2, okay, the x variable. So for that, first you need to find x1, y1, okay? X1, y1 is going to be equals to x0, y0 minus the same one. Eta they have mentioned as 0.2, so minus 0.2 into minus 0.2 into this lower by dou x lower by dou y. So dou by dou x it's going to be equals to 2y plus 2 minus 2x. Okay, because 2xy it's going to become 2y, 2x it's going to become 2, and minus x square it's going to become minus 2x. 2y square partial derivative with respect to x is 0, so that will not include. Similarly, partial derivative with respect to y, it's going to become first 2xy it's going to become 2x.
2x minus 4y.
Yeah, plus no, not yeah, minus 4y.
2x minus 4y.
Yeah, so if we substitute the value of minus 1 comma minus 1, it's going to be minus 1 minus of 0.2 into what is the value? It's going to be 2y. 2y is going to be minus 2 plus 2 it's going to be 0, minus 2 of minus 1 it's going to be 2, and then this 2x minus 4y it's going to become
It's 2 and 2.
plus 2, right? Am I right?
Yeah.
Okay, so now this is going to become minus 2 into 2, it's going to become 0.4. 0.4, so
Minus 1.4.
it's going to be
0.4,
Minus 1.4.
minus 1.4, minus 1.4, right?
minus
Yes.
1.4, minus 1.
Correct?
Yes.
Okay.
Yes.
So this is what we have until now, and then we need to find x2. Okay, x2, y2. I need not find this y2, but then I'm just writing it here. It's going to be equals to x1, y1 minus of same point into dou by dou x, that one. So the formula is this: we have this 2y plus 2 minus 2x, right? And 2x minus 4y. Now it is minus 1.4 comma minus 1.4. Okay. This is the point. It is substituted here. Minus 1.5. I need not worry about it because they did not ask me to compute this. So it's going to be minus 0.2 into some. It's going to be 2y minus 2x. So it's going to get cancelled out. So it's going to again become 2 here.
Minus.
And then here this 2x minus 4y. It's going to become minus. Since it's the same, it's going to become 2.8. Am I right?
Yes, sir. 2.8 is.
Okay, yeah. So this actually I did not even have calculated because we only require this x2 here. We only require x2 and we don't require y2. They didn't ask us to compute y2. So now it's going to be equals to minus 0.4 plus minus 1.4. It's going to become minus 1.8. Okay.
Yeah.
Okay.
So x2 is minus 1.8. Okay. So this 2 is done. Now we'll move on to the next problem. Okay. Now this one, at what value of x will f of x equals to 2x minus 8 whole square be minimum? This should be pretty straightforward, I guess. I'll give you guys 2 minutes to solve this and then we'll look at solution. Okay. It's going to be just 3 minutes. All you need to do is like differentiate it, equate it to 0, and you'll get the value of x. Don't mention answer. Okay. Please don't mention answer in chat box. Okay. So we'll look at the solution. See, it's straightforward. We have here for this course formulation, we have this f of x equals to 2x minus 8 whole square. We need to find the minimum. The minimum value, since it is square, right? The minimum value possible is 0, right? So that could happen when 2x minus 8 is 0, which will give you x equals to 4. Okay. If you want to find it exactly mathematically, you could do it like f dash of x, which is going to give you 2 into 2x minus 8. Okay. And into 2. Okay. For we'll get the minimum value when f dash of x is 0. So when we equated this to 0, you get 2x minus 8 as 0. Okay. Which will give you x as 4. Okay. So that is a problem. Is this clear?
Yes.
Yeah, yes, it is.
Okay. We'll move on to the next one. Assuming x naught equals to 2, right? We found that the minimum value occurs at x equals to 4, right? Assuming x naught as 2 and eta equals to 0.05, what is the number of iterations required to reach x in the previous question using gradient descent? Okay. Clear? So basically, we need to be reaching this x equals to 4, right? Assuming eta equals to 0.05. For that, you need to find the number of iterations required to get there. Okay. Using gradient descent. Is this clear? Hello, is this clear? When they mentioned consider error of 0.1, what they were saying is the required value which you get, right? It won't be exact. It might not be exactly equals to 4. So if you get if whatever value you got, if it is like the error is like less than 0.1 or equals to 0.1, then that is acceptable. Okay, so you could stop at that particular iteration. Okay, is this clear? So suppose you got 3.88, right? 3.81 or something, then the error is more than 0.1. Okay, so you should move forward. Like, but if you got somewhere around 3.92 or 3.9, then you could stop. Okay. So this I'll give some 5 minutes to solve, and after that we'll look at solution. Okay. This is just a computational one. Okay. It might require more time. Okay, so shall we look at solution? Okay. So ideally, I'll just tell you the process for those of you who are like trying to solve it like number of iterations. That is just like repetitive work. Okay. So let us just look at the process. Okay. We have this. And you know what do we have? We have this. We have this f of x. Okay. And we were given x naught as 2, right? And for our final x value is 4, right? So basically we should be reaching to 4. We should find out the number of iterations required to get there. And eta is given as what? 0.01. Am I correct? Oh, it was 0.05. Okay. So first thing we need to find f dash of x, right? F dash of x is going to be equals to 2 into 2x minus 8 into 2. It's going to be 4 into 2x minus 8, correct? Am I right? Okay. So for first iteration, what do we have here? We have x1 equals to x naught minus eta into f dash of x, right? Eta into f dash of x. Substituting those values, we get f dash of x naught. So x naught is 2 minus eta is 0.05, and then f dash of x at 2 is 2 into 2, which is going to be 4. 4 minus 8 minus 4 minus 4 into 4 minus 16, right? Into minus 16 is going to be equals to 16 into 5. Can someone tell me what's going to be that value? It's going to be out. It's going to be 0.8. So 2 plus 0.8. It's going to be 2.8. Okay. This is after first iteration. Okay. Now if you move on to the second iteration, now it's going to be the same thing. X2 is going to be equals to x1, which is going to be 2.8 minus 0.05 into this f dash of x. F dash of x now it's going to be f dash of 2.8, which is going to be 4 into 2 into 2.8 minus 8. What's going to be that value? It's going to be equals to it's going to be minus 2.4 minus 2.4 into 4. That's going to be minus 9.6 in total. Okay, that is your f dash of x. So substituting here, minus 9.6, what you get is you get 2.8 plus 0.48, which is going to be 3.28, right? Until now, am I correct? Any mistakes? Any calculation mistakes?
No, it's correct.
X1 is 3.844. Okay, you're just saying this value is okay. So for third iteration, we have x3 equals to same thing again, 3.28 minus 0.05 into 4 into 2 into 3.28 minus 8, right? Which is going to be equals to 3.28 plus it's going to be 0.07, right? It's going to be 0.288. It is going to be equals to 3.568. Okay, 3.568 after third iteration. Now after fourth iteration, what we'll be having is x4 equals to 3.568 minus 0.05, and then just keep on repeating. It's going to be 0.864. Okay. into 4 will be having. So it is going to be 3.568 plus 0.1728. We just compute that. You're going to get 3.7404. Okay. We are like slowly approaching the value. So we have 3.7404. Now, right now the error is 0.25, right? So we should still be computing minus 0.04 into so this is going to be equals to 3.7404. I just computed this value, right? By substituting this 3.7404, we'll get it as something like 0.10368, which is going to give you 3.7404, which is going to give you 3.84408. Okay. And in the sixth iteration, what you want to get is you want to get x6 as 3.84408 minus 0.05 into 4 into this 2 into 3.844. I just have it until that minus 8. It's going to be equals to give me a minute, I'm just computing this value. It's going to be equals to 3.84 plus 0.0623 something. Okay. So we just add it to this. It gives you somewhere around 3.906 something. Okay. So right now, since our value is like more than 3.9, right now the error is like less than 0.1. So after six iterations, right? After 6 iterations, you'll be getting the value close to that. So yes, the answer is 6. Okay. The number of iterations required to reach x is 6. Okay. And now we can use the same problem. Okay. Using Newton's method for optimization for the same problem, find the number of iterations required to reach x. Okay. Obtained in Q1. Okay. You can just try this. Okay. Using for the same problem, that is this f of x equals to 2x minus n whole square, right? Use Newton's optimization method and find out the number of iterations required to reach this 4. Okay. You can just assume the same problem again, but instead of this gradient descent method, you just use this Newton's method. Okay. This should be easier. This should take you, I hope, less number of iterations, so less time. So I'll give you like 3 minutes to solve, and after that we'll look at solution. If you completed, please raise your hand. Okay, so shall we look at solution? Okay, so let us look at this solution now. What we have over here is that xn plus 1 equals to xn minus f dash of x by double dash of x, right? So we have this f dash of x as 4 into 2x minus 8, correct? It's going to be f double dash of x, it's going to be 8, right? Correct? F double dash of x is going to be 0, and then is this 8x, if it just differentiate with x again, it's going to become 8. So now this xn plus 1, it should be xn minus 4 into 2x minus 8 divided by 8. Okay, substituting x equals to 2, what you get is get 2 minus 2 minus here you have is 4 into 2 to the 4 minus 4 divided by 8, and then you'll be getting 2 plus 2 directly 4, right? In the first iteration itself, you're able to get the exact solution. It's not even like approximate. You're able to get exact solution. Okay, but then this occurs for only for second order, right? For second order, since this is since the function here, what we have is 2x minus 8 whole square, that is of second order, right? The degree is 2 there, so that is why you're able to get in the first iteration. In the first iteration itself, we'll be getting exact solution. Okay, but for higher orders, you still need to do some iterations like we do for gradient descent. Okay, right? Is this clear?
Yes.
Yeah. Okay, so now consider this function f of x equals to x cube minus x square minus x plus 5. At which positive value f of x is minimum? So that's a question. Okay, this is also similar to the previous one. You just need to differentiate it and then solve for it. Okay, I'll give you 5 minutes to solve for this, and then we'll, not 5 minutes, 3 minutes to solve for this, and then we'll look at solution. Okay, so we'll get the solution now. B f of x is given as x cube minus x square minus x plus 5. Cube minus x square minus x plus 5, right? F dash of x is going to be equals to 2x square, sorry, 3x square minus 2x minus 1, right? So this should be what? 3x square minus 3x plus x minus 1. So this should give you 3x into x minus 1 minus 1 into plus 1 into x minus 1, right? Am I right? This should be 3x plus 1 into x minus 1, right? So for us to get the minimum value, this f dash of x should be equal to 0. It should give you either x as minus 1 by 3 and x as 1. Okay. So there are like two ways to check here. One is you could substitute both of these values, and then whichever gives the minimum value at that particular x value, you'll be getting the minimum. Okay, and then that is the minimum value. Okay. Or the other way is you could do the f double dash of x. Okay, and f double dash of x, if it is greater than 0, then at that particular point it will be minimum. Okay. So we'll just substitute it here because that's easier. What do we get is we get 1 minus 1 minus 1 plus 5, which is going to be equals to 4, right? And then if we substitute minus 1 by 3, then I do not think that will get the minimum value. Okay, it's going to be more than 4. Okay, because it's going to be by 3 whole cube minus plus minus 1 by 9, and then plus 1 by 3, right? Plus 5. Okay, so this is going to be more than 4. So at x equals to 1, you'll get the minimum value, and at x equals to 1, you'll get the minimum value, and the minimum value is equals to 4. Okay, clear?
Yes.
Okay. So for the same problem, right? X cube minus x square minus x plus 5. Assuming initial case of x naught equals to 0.75 and the step size of 0.25, what is the number of iterations required to reach x? Okay, using gradient descent method. It should be considered here the error of 0.001. Okay, just like we have done for this problem, right? We should be solving for here. Here, the x value which we should be reaching to is 1. Okay, initial assumption which they gave is 0.75. So how many iterations is required to go from 0.75 to close to 1? Okay, how close? It is this close, 0.001 error close. Okay, yeah, try solving this and then we'll look at solution. So try solving this, and then meanwhile I'll take 5 minutes break and then we'll look at solution. Okay, so shall we look at solution? Hello, shall we look at the solution? Okay, so let's look at the solution now. The data is given as 0.25. Okay. We have this set of x equals to this x cube minus x square minus x plus 5, and then f dash of x is 3x square minus 2x minus 1, right? So on x naught is given as 0.75, x1 will be equals to 0.75 minus 0.25 into this f dash of 0.75, which is going to be equals to 3 into 0.75 whole square minus 2 into 0.75 minus 1, right? It should be equals to, what will be the value? Can someone tell me?
0.9531.
This is 0.9531. This value?
The overall x1 value.
Okay. I'm not talking about the overall x1 value, I'm just talking about this value. This is going to be equals to 0.75 into 0.75, which is going to equal to 0.5625 into 3 minus 1.5, then minus 1. This is going to be equals to minus 0.8125, right? So minus 0.8125, which is going to give you this value as 0.9531. Okay, to 5, but then this is the value of x1. Okay, right now the error is 0.05 something, 0.04 something. Okay, 0.047. Okay, but since we want the error to be 0.001, so we need to continue further. So x2 will be equals to 0.953125 minus 0.25 into the same thing, 3 into minus 0.7, sorry, minus 0.953 whole square, same thing again. Okay, so 0.953125. Can someone tell me this value? What is this f dash of x for this? F dash of 0.953, can someone tell me? Minus 0.1809. Okay, thanks. Minus 0.1809. This should give you the overall value as plus 0.953125. It's going to give you 0.99835. Am I right? Yeah, 0.99835. And then the x3, if we just compute this, it's going to be here the error is of the order 0.00117, right? 17 approximately. So we should continue further, but we are almost there. It's going to be 0.99835 minus 0.25 into f dash of 0.99835. Can someone tell me what is this value? F dash of 0.995. That's going to be, okay, thanks. So it is minus 0.00658 approx. Okay, 6. So this should give you 0.99835. 0.00658 into 0.25 plus 99835. This has given me 0.995. Okay. So our value is close to this. Okay. So here the error is less than error is less than 0.001. So after third iteration, we were able to get this, get the value of x. Okay. I mean, get the minimum value. Okay. All right. So this is the last problem. Okay. And then we'll bind it up. So for the same problem, using the Newton's method, we need to find the x. Okay. The same error 0.001. All right. For the same problem, that is x cube minus x square minus x plus 5, right? And starting with x naught as 0.75 and eta. Okay, here you won't be having this theta. Okay, so you need to be finding after how many iterations you'll be able to get this x value. Okay, x value as 1, close to 1, with error of 0.00. If you're completed, please raise your hand. After 2 minutes, we'll look at the solution. Okay, so let us look at the solution now. Shall we look at solution? Okay.
Yeah.
So now for this, we need to find this f double dash of x2. So what is f double dash of x? F double dash of x is we didn't find it, right? We didn't compute it. Okay, it's going to be equal to 3x square minus 3x plus 1. This you should be differentiating, so it's going to become 6x minus 3. Okay, so f double dash of x is 6x minus 3, and then f dash of x is that same thing, 3x square minus 2x minus 1. Okay, so for x1 we need to find this x naught minus f dash of x naught by f double dash of x naught, right? So we already computed this value of f dash of 0.75. That is, what's that value? Minus 0.812, right? So we have
Sir,
here
f double dash x is 6x minus 2, right, sir?
if f dash of x equals to 3x square minus 2x minus 1.
Okay, yeah, right. So it's 6x minus 2. Yeah, you're right. Okay. Yeah, it's 6x minus 2.
6x minus 2.
Okay, so now we have this, it says 0.81, what's the value? F dash of 0.75. It is 0.8 minus 0.8125.
Hmm.
So minus 0.8125 divided by this 3 into 6x minus 2. It's going to be 6 into 0.75 minus 2. What's that value? Can someone tell me? 6 into 0.75, that's going to be equal to 3. Oh, no, it's not 3, it's 4.5. 4.5 minus 2, it's going to be
2.5.
2.5. It should be, now this value, it should be
2.5, sir.
0.8125 divided by 2.5 is going to be equals to 0.75 plus 0.325. Okay. The answer which you get is
1.075.
yeah 1.075, right? Okay. So here we got like more than one, but then the error is like more than one here. Sorry, more than 0.001. So we should go to the second iteration. X2 as 1.075 minus f dash of 1.075 by f double dash of 1.075. Okay. If you just compute this, it's going to be 3 into 1.075 whole square minus 2 into 1.075 minus 1 divided by 6 into 1.075 minus 1 minus 2. Sorry. Can someone tell me this? This value. Did anyone compute that value? Okay, let me do the calculation then. Three into 1.075 square
Sir,
divided by
upper value will be 0.315 by 4.45, sir.
divided by 4.45. Okay. So that's going to be equals to minus point. So it's going to be equals to 0.0712. Okay. So let me just
Yes,
write
sir,
this down here.
0.075.
1.075 minus 0. 0.07, right? Minus
Yes, sir,
0.07125, which is going to give me 1.075 minus 0.07125, which is going to give me 1.00375. Okay, it is still less. I mean, our required error should be less than 0.001, so we should still move forward. So x3 should be 1.00375 minus f dash of 1.00375 divided by f double dash of 1.00375. Okay, this value alone, if I compute, can someone tell me this value? First compute the f dash of 1.00375, and then this one. Okay. So it should be equals to f dash of x is 0.015, 0.015, 0.0150. Okay. So 150,150,421. Then if you compute double dash of x, it is 6 into 1.00375 minus 2. Okay. That is 4.0025. Sorry, 4.0225. So this value should be equals to 50. This is 0.003739. 0.003739. Okay. So 1.00375 minus 0.003739. This should be here. Now we'll be getting this approximate value.
It will equal to 1, sir.
Yeah, this is not exactly equal to 1, but then
Yeah, 1.0003.
1 something. Okay. After 4 zeros, you have
1.
105. Okay. So here the error is less than 0.001. So yeah, this is after third iteration, using both this both the Newton's method and the gradients method, we were able to get the solution. Okay. So that's it from this. Okay. So that's all we have for this. Okay. Yeah. If you do not have any other questions, you can close the session. Okay. So thanks everyone.
Thank you, sir.
Thank you.